Alright folks, Eric Wooldridge here with the Additive Guru channel, and in this episode we're going to talk about your temperature settings and some of the ideal target temperatures for your basic 3D printing applications. I'm using Cura as the demonstration and also a 20 unit or 20 by 20 solid cube for my application here. You can always find something like that on Thingiverse, and of course Cura is easy for download. Now when you go into your standard quality settings, you have your option which shows up right here for custom. I'm going to click to custom, and I'm going to expand the material option right here. Now different slicers control this in different areas. This one, Cura, controls it under the materials category, but we are going to focus on these values right here: the temperature of your print bed and the temperature of your build plate, and of course they got the retraction. We'll talk about that too. So let's talk about first this whole printing temperature. What is the printing temperature? The temperature that your nozzle is producing, or your heat block is producing, as your filament comes out. And how hot is too hot? Is 200 degrees Celsius good? Is 180 good? Is 230 good? And it's all based on which material you're using. Now, a lot of printers like to use PLA. And this printing temperature can range anywhere between 200 and oftentimes we run it at 230 in the lab. Now, why do we do this? Well, there are some benefits to a higher temperature. One thing that we have seen the studies show, that a hotter temperature within reason of certain materials gets a better layer to layer bond. And that's one of the things that we're really interested in 3D printing, because as you have an object and you lay down one layer and you lay down the next layer, you're very much interested in how strong the bond is between this layer and the one after that and the one after that. And there is an increase in bond strength. Write that out for you. Bond strength, or B strength, with an increase in temperature. Now it has its limits as to how far that goes, but you can get a little bit better layer to layer strength by increasing the temperature. So for PLA, we oftentimes run it at, we'll start off at the first layer at 230 oftentimes, and then we'll actually tell it to back off to maybe 220 or 215 after that first layer. Now you don't see that option in this particular case, and that's okay. Some slicers set it up differently. But our first layer printing temperature, we usually like it high to get a good layer to adhesive material bond on your build plate, and then let it cool down just a little bit after that. Now in other materials, for example, you switch to polycarbonate, any kind of more exotic material than PLA, you're typically going to be running 230, sometimes all the way up to 250, and in some cases to 260. And then there are some materials that are 300 and higher, depending on if your printer is capable of doing those temperatures. And that's when you start getting into materials like PEEK and Optimum and those kind of things. For most desktop users, they're going to be using variants of PLA, maybe some PETG, ASA, those kind of things, and they're going to be somewhere in this 200 to maybe 250 degree range. Now as far as print time, doesn't make a whole lot of difference in the trade-off there. You can get too hot, and if you get too hot, then the material actually doesn't flows too well, and your extrusions can be a little bit stringy. And also what can happen, especially with certain FDM type printers, is if you get it too hot, you will get what we refer to as heat creep. Let me just show you here. So this is your nozzle, and this is where your material is flowing out. There's oftentimes a radiator or fin system in between with a little fan on it, blowing air across it in some form or fashion. And the idea is that it keeps this heater block from heating up too much up this way, where your plastic is coming down through a tube of some type. And if this gets too soft due to heat, then it creates clogs. We often refer to this as heat creep. And you don't like heat creep because it causes you to have clogs, it makes the motor jam up here, and all kinds of problems. So sometimes if the material doesn't call for it, over raising the temperature too high is going to create a clog issue, and so you want to watch that just as well. Now you go too low and then you don't have a good layer-to-layer bond, it doesn't flow well, and you have to watch out. Now, easiest way to know is to check your manufacturer of your filament, and they'll typically tell you what temperature range to run at. We generally run a little bit on the hotter side of whatever that range is. So in the case if I were doing PLA at this point in time, I would probably go ahead and raise this up maybe 220, maybe 230, just depends. The other thing is the build plate temperature, and what that matters to you in terms of the application and the technician. What temperature are you heating up the build plate to? If this is our build plate and our box on top of it, how hot is the temperature here in terms of good performance? Now, we typically run our build plates at around 60 degrees, maybe 70 degrees Celsius, because we find some of the materials that we use for adhesion do better with a little bit of heat. Now, there are build plates out there that don't operate with heat at all, and so they're cold beds, but they use a different type of material to adhere. This does range in terms of what the build plate material that you're using recommends, and for what materials. And there are different reactions between the build plate adhesion and the material you're using to print with in terms of what is an optimum temperature. Again, most manufacturers will give you recommendations on what temperature you need to set this to. Generally, a good rule of thumb is what we typically use, maybe 50 to 70 degrees Celsius for your build plate. However, I will point one thing out in some of the studies that we have done in terms of environmental effectiveness and actually environmental benefits. The lower the build plate temperature, the less power is consumed with the 3D printing process, and the better for the environment the actual 3D printing process can be. So if you are looking at it from a sustainability standpoint, the lower you run the build plate and successfully produce your parts, the better you are for the environment, because it essentially uses electricity. The amount of electricity used by the nozzle to heat up for its filament is extremely small, because the heat block itself is a very small thing on an extruder. And if you're not familiar with what I'm referring to, let me show you a picture. Here we go. This is a good shot. And so your heat block is actually down here. There's your nozzle, and this is actually part of the heater cord. Typically there's a little heater resistor that's installed right at this point, and this heats up the block, which heats up the filament as it passes through right above the point of the nozzle. You see your cooling fins right here to avoid heat creep, and this is your drive motor, which is pushing the filament while it's still nice and cool and stiff, all the way down through this zone, through basically your radiator system to hit the heat block. But this heat block is so small and this heater core is so small that it generates a lot of heat right here, but it doesn't generate a lot of heat overall. So this thing actually uses very little power in terms of performance. The majority of your power associated with a 3D printer is really going to heat up the heat bed, which is part, of course, your main build plate. That I'm sure there's an image right here for us to use. Shoot. Your heat bed, of course, being down in this area, this being your heated bed, and that's where the power is really going to. And a lot of different printers operate, some operate off an AC heat bed, and that means alternating current, which means it's still running at the same type of voltage that your typical wall outlets run at, or DC, which is taking it from your wall out to a 24 voltage application, which is higher amperage. So anyway, that's where the power is consumed, not a whole lot here. So if you are interested in performing a little bit better in terms of environmental friendliness, then you might want to try to lower your build plate. Oops, that's a little feature I didn't realize. Lowering your build plate below that. But a typical range for good adhesion is going to be somewhere between 50 and 70. A lot of people average it out at 60 degrees Celsius. Now, one more feature while we're here, and that is the retraction. So what is this retraction thing? Well, let me go back to a picture on the screen here, and let's look at our extruder again. Maybe this one will work better. So, yeah, this will work. So as filament is coming down and being pushed by the direct drive motor down through this tube that you see with the radiator fins down to a heat block and heated, creates like a little tiny pool right here. Now, many of you have probably seen this when you actually have your printer going and the nozzle, when it's heating up, you'll see a little drippage of plastic coming out as the heat block's warming up. This happens throughout the entire printing process. There's always a sort of molten plastic material that is being extruded out, and what we can do is we can turn on retraction, that instead of this wheel pushing down to push the filament down, it will turn around and very quickly jerk it back up to sort of suck the loose plastic back up into the system. This can stop the whole process of the stringing pieces of filament from one section of a part to the other. Let me give you an example. Here we go. So, great little example of why you should do retraction, because you have the strings of little bit of strands of filament from one spot to the other. Another good example is right here, where the individual has retraction turned off and retraction turned on. For most materials, you will have retraction turned on. However, there are some materials that you don't want to have retraction, and that is typically materials that are designed to be flexible. Materials like Ninja Flex or TPU, materials that are designed to be have objects that have flexibility to them, you would want to turn that off, because with soft materials, retraction doesn't work really well, or you can at least slow it down. So that's what that feature is for. Most of the time, especially when you're just getting into this type of work, you're going to leave this turned on until you switch to flexible materials. Alright, so that's a brief little overview on temperatures, build plate, and printing temperature. Always again take a look at the material settings that are provided with your filament manufacturer. They give you some really good recommendations. Again, we go on the high side just because we see a little bit stronger layer-to-layer bond with a little bit higher temperature. Alright, thanks for watching, and if you have any other questions or anything, you can always reach out to us and check out some of our other videos. You might find something interesting. We'll see you.